Hello, Chris. Can you help me with something?
Kian? Kian? Lindor? Kian?
I'm here.
Kian? Are you okay?
I'm okay. Solve the problem.
If a closed tin can in the shape of a right circular cylinder of volume 16 pi inches cube, find the height and radius if the least amount of materials is used to manufacture the tin can. Thank you. Steps, Kian. First is we name the variables and restrictions. So we can see the problem. We've got 16 pi inches. So we write here in the given. The volume is equivalent to 16 pi inches cubed. And we know that it is a right circular cylinder. We also know that we have to find the height and the radius. We've got 16 pi inches cubed is equivalent to pi r squared height. Since we are trying to find the height, because it's the easiest, because the radius here has squared, so we divide both sides by pi r squared. We've got a final answer of height is equivalent to 16 pi inches cubed over pi r squared. So we set a restriction because according to step 1, we set restrictions. Now we know that we are going to find it using a right circular cylinder. So when we are trying to find a right circular cylinder with height and radius, we are finding its surface area. So the formula of the surface area of a right circular cylinder is S is equivalent to 2 pi r height plus 2 pi r squared. So the next thing we're going to do, write the function to be optimized. Since we've got height, we're going to input this value here. So we've got surface area is equivalent to 2 pi r, write it down, 6 pi. We're not going to add the inches anymore because we're going to have a solution. Over pi r squared plus 2 pi r squared. So the next thing that we're going to do is that since there are 2 pi's here, we can test it out. This is how it's going to go. 6 pi. We're not going to multiply this between yet. We're going to focus on the r squared. It's going to be r to the negative 1. Because we're going to divide r by this. We have a formula that a r over a n is equivalent to a r minus n. That's how we got here. Next, we multiply it by pi r to the negative 1 plus 2 pi r. So the next thing that we're going to do is we're going to get the first derivative. So we have s is equivalent to 32 pi r to the negative 1 plus 2 pi r squared. So this exponent goes down and we have to subtract 1 from it, as well as this side. So we've got negative 32 pi r, negative 1 minus 1 is equivalent to negative 2, plus 2 times 2 is 4 pi r, 2 minus 1 is 1. So we're not gonna write the 1 there. So we're going to factor out the similarities with this. So the similarities for this is 4 pi r to the negative 2. So we have negative 8 plus r squared is equivalent to 0. Okay, so the next thing that we're going to do is that we're going to place this downward. So we've got 4 pi over r squared times r cubed minus 8. Next is we're going to factor this equation out. So we've got 4 pi over r squared, and we've got r minus 2 times r squared plus 2r plus 4. The next thing that we're going to do is we're going to use the Dpp property. So this is already 0. Next is this is equivalent to r is equals to 2. And when we try to look at this does not exist. So why does this does not exist? First and foremost, let us look at here. The signs in between, you see, when we try to get 2 here, we need a subtraction for the other one. However, we see in the sign here that this is positive. Therefore, this doesn't have any answer. That's why we have an r is equivalent to 2. The next thing is we're going to plug this into the equation to get the corresponding local or minimum by the second derivative test. So the next thing we're going to do is we're going to find the extreme values using the first derivative or second derivative test. Since we've already used the first derivative, let's move on to the second derivative test. So we have the first derivative of first derivative is equivalent to negative 32 pi r to the negative 2 plus 4 pi r. So the next thing that we're going to do is we're going to derivatize this. Is that even a word? I don't know. Next is we're going to put this down and then we're going to subtract 1 to it. And this the same, and I'm going to subtract 1 to that. Then we have a positive. 2 times 2 is 4. 2 times 3 is 6. So we've got 64 pi r to the negative 2 plus negative 1 is negative 3. Plus 1 times 4 is 4 pi r. 1 minus 1 is 0. Therefore, that's 1. That's 1 there. So this is already the second derivative. So we're going to plug in the r that we get from the other equation here. So we're going to do that here. We're going to replace the r with 2. So we've got 64 pi 2 to the negative 3 plus 4 pi. Next is we're going to put this down because since this is a negative, since this is a negative exponent. So we've got 64 pi over 2 to the power of 3 plus 4 pi. Then we move to the lowest term. So this is going to be 8. 8 divided by 64 is 8. So we're going to push that out. So we have 8 remaining. And then we're going to plus that with this 8 pi with this 4 pi. So we've got the result of 12 pi. Since 12 pi is greater than 0, we therefore approve that r is equals to 2, which corresponds to the local minimum by the second derivative test. So after this, we're going to plot the r2 to the beginning of the equation in order to get h.
Wait, lakas lang. Go.
So the very first equation that we're going to do, we already know that h is equivalent to this equation right here. So we've got height is equivalent to 16 pi inches cubed all over pi r squared. The pi is pushed out, and then we are left with 16 inches cubed over r squared. So the r, we already know it's 2, so we're going to replace that with that. So we've got 16 over 2 squared inches cubed. So the next thing that we're going to do, this is equivalent to 4. And we're going to do the lowest term for part, so this is equivalent to 4 as well. So therefore, our height is equivalent to 4. It's so dark in here. Kia.